In December of 2023, the SPEE3D team faced a trial that pushed the boundaries of metal 3D printing. The U.S. Department of Defense's Point of Need Cold Weather Challenge was conducted in Hanover, New Hampshire, where the team was tasked with using SPEE3D's cold spray metal additive manufacturing process to print a set of parts in a lab environment and then replicate the process in sub-freezing conditions. The objective was to determine the cold temperature's effect on the printer and on the material properties of the printed part. In addition to the predetermined parts, the team also printed parts introduced during the trial. XSpeed, SPEE3D's deployable metal 3D printer, was tested in this exercise. Developed based on field trials with the Australian Army, XSpeed is a ruggedized unit capable of fabricating metal parts up to approximately 3 feet by 3 feet in diameter and up to 90 pounds, all in hours and days versus the weeks it takes to produce similar parts via traditional methods. This challenge was designed specifically to explore the complexities of manufacturing metal parts on-site in sub-freezing weather conditions.
Up until this point, we've had a lot of success in other austere environments. So we've been in deserts, we've been in the bush, we've been in very humid environments, we've been in seaside on multiple occasions with the corrosion there. So this is the first test in cold weather to see if we could take it down sub-zero. So take it down to, I think we got it down as far as about minus 10 to 20 Celsius, and then heat it back up to see what the impact would be.
The ability to print at the point of need is a game changer for defense, especially in cold weather. The technology offers a solution to logistical challenges in getting parts to remote locations, ensuring less critical downtime.
Logistics is a problem for everybody, right? Not just at any time, but in cold weather, could be snow, could be ice. That makes getting parts where they need to go difficult. And being able to print at the point of need can really be a game changer for defense in general. Not having to rely solely on long supply chains that can be backed up by weather. You can print right at the point of need and get the warfighter what they need.
SPEE3D's XSpeed technology offers two primary applications: immediate repair parts and short to mid-term replacement parts. This means you can make repair parts on-site for immediate use or produce more durable replacement parts at a base with post-processing capabilities.
The Army is really looking at lots of different solutions for how do we create what we need in a deployed environment. And cold spray as an additive manufacturing solution is one possibility that offers a lot of potential. And what it is you can do with the different metals you can use with cold spray really opens the aperture up in terms of potential solutions.
During the trial, a wide range of parts were printed, from tools to replacement parts for military vehicles, such as a wrench, a sternum breaker, a door handle off a Humvee, and a battery lug, as well as additional parts for testing. The results of the trial showcase that the printer operated smoothly, and even unexpected parts provided on-site were handled without setbacks, demonstrating the technology's robustness and versatility. The part samples were then sent to SPEE3D partner New Jersey Institute of Technology for testing. Results showed that the parts well exceeded SPEE3D's data sheet minimum for material strength in terms of both yield and ultimate tensile strength. The cold test showed only a minimal change in ductility. The trial affirmed SPEE3D technology is capable of completing missions in below freezing environments and can produce parts that meet the same material expectations as those produced in a laboratory. From below freezing to the intense heat of the Australian bush, SPEE3D technology is able to work alongside you to produce strong, durable, large metal parts when and where you need them.